at IEEE VIS on deep learning. My name is Torsten Noller, I'm the session chair, and I'm really excited to have 5 wonderful papers being presented in this session. It will be framed by a couple of papers by Georgia Tech, so we'll start and finish with Georgia Tech. I'm very happy to have Fred here ready to talk about visual analytics and deep learning, an interpretive survey for the next frontiers. Considering the title, he'll be talking for 2 hours, and after that there will be questions.
All right, great. Can everyone hear me okay? So thanks for the introduction. I'm Fred Hellman. I'm a PhD student at Georgia Tech. And on behalf of my co-authors up here, I'm really excited to be kicking off this session on deep learning, where I'm going to be presenting a survey paper for visual analytics and deep learning. So regardless if you're a novice or an expert, you've likely heard something about deep learning recently, which involves typically the study of learning representations of data using deep neural networks to perform some sort of predictive or classification task. But like any model class in machine learning, neural networks have a number of different problems they suffer from. Luckily, visualization is here to help, and has helped to alleviate and even solve some of these problems. And in fact, over the past couple of years, there's been a number of different visual analytics systems, all targeted at aiming and assisting some facet of neural networks and deep learning. So as we were looking at the state of the field, just a couple of months ago, we thought it'd be really nice if there was some concise organization of all these works so that researchers and practitioners could come and look and find what problems have been tackled and then which ones could also be ripe for some more exploration. And that's exactly what we did in the survey. So with this talk, you'll hopefully take away 2 things. One is a number of research trends that we see that have already been tackled quite a bit in literature. Some common patterns I'll also point out today. And then second, some research directions where there's been a little bit of work starting to come up, but we think there's going to be a lot going here in the next couple of years. So before we get into just a bunch of highlights that we found from our survey, I thought I'd just talk about how we went about doing it. So if we just consider this abstract view of what it means and how to use a deep neural network, you see it involves people, models, visualizations, and it's this giant complex workflow involving a bunch of moving parts. So when we looked at this, it inspired us to take an interrogative approach often done in journalism by asking question words to really structure the space. So for example, the first one we might ask is just why? Why are we doing this? Why would anyone want to visualize deep learning? Similarly, we could ask who. So what's our user group? What people could benefit from visualizing deep learning or even just use it? Continuing, we could ask what are the data features, relationships, models, types of things we can even visualize. And once we have those things, how do we go about visually encoding them to make the visualizations we want to use? Next, it might be worthwhile to ask when is it appropriate to actually be visualizing deep learning, before the training process, during, after. And then lastly, where has all this been used? Has any of this been used in industry, deployed? Is it all just in academic papers, etc.? So using all these questions, we did a multi-domain survey. We did a bottom-up approach where we gathered all the visual analytics systems. We took their interfaces, their interactions, the contributions from their papers, and all their design methodologies, and we grouped them into a bunch of different categories that I've listed here. Now, we're not going to talk about all these today, but if you go to the paper, we do have some discussion about each one of them. It's also important to note that this list is not exhaustive. But it's rather just present to what we see in the literature today. So there could be things that come up in the future that is not currently on this list. But to do just a little bit of a summarization for the talk today, if we just consider all these categories and we rotate them into the headers of some big table, we can actually have the headers of these categories and the rows be all the works that we surveyed here. These are all visual analytics systems. We tried to focus on things that are highly interactive and move away from just static viz. So to better give you an idea of how this all works, I just wanted to go through one quick example, and then the remainder of the talk is going to be a bunch of highlights that we found. So the one example I'm going to use is this paper called ActiViz, Visual Exploration of Industry-Scale Deep Neural Network Models. This is done by one of my colleagues at Georgia Tech, Vincent Khan, who's actually going to be closing the session with some different work presenting today. But this is with collaboration with people at Facebook that he presented last year at the VIS conference. So we're just going to rotate his categorization here on the right and quickly step through how it fits into all these questions before we get into some of our highlights. So the first one we always start with is why. Well, ActiViz is an interactive interface that hopes to support interpretability and explainability of neural networks, which we likely all know in this room is one of the most pressing problems with this model class. We're going to talk about that a little bit later today as well. But it also aims to debug and improve models. Like I mentioned, this was done with collaboration with folks at Facebook, and they're really interested in squeezing out performance of their big models. If we continue on to who, this was primarily to be used by Facebook data scientists and machine learning engineers. So these are truly expert users who, like I said, are looking to squeeze out performance of these neural network models. If we look at what they visualize in, they are taking the network architecture, they're using activations from neural networks, as well as instance groups and some aggregated information here. And they visualize that by using a node link diagram on the top, some dimensionality reductions and scatter plots there in the bottom, some instance-based activation tables, and then also a unit visualization there on the right-hand side. This is a system that is used after the training process is completed. So once you train a model, you save all the weights and you load it into this system. And then, like I mentioned a couple of times now, this was published in TBCG, presented at VIS last year, and then deployed on Facebook's internal machine learning platform. So this is just one example of how a visual analytics system can fit into our survey schema. And all the rows from that table that you saw earlier all have a similar categorization. But now I just want to get into 8 survey highlights that we found as we did this process, which are all listed below. So we're going to talk briefly about each one of these things. And the first 4 are a number of research trends. So this is common themes we see going on today. And then the last 4 are going to be some research directions where there's a little bit of work, but we think that's going to be continuing a lot more in the future. So let's first start with model interpretation. So we're going to bring up our table here on the right. I want to focus in on that first column of why, and then one sub-column which deals with interpretability and explainability. And we see that of the 38 papers in this table, 36 of them support model interpretation. So that is an overwhelmingly majority of them. But even though there's so much work focusing on this problem of interpretability, there still is no formal agreed upon definition of what it means to be interpretable. If you read the literature, seemingly everyone agrees that it should relate to some human understanding of something, but different papers have different definitions of it should be if a model's internals, operations, the mapping of its data, or its learned representations should be human understandable. And it could be that interpretability remains this umbrella concept that describes a whole field instead of achieving some precise definition. Okay, so the next one is going to be the column over, so the who column. We're going to focus on one sub-column, which is all about the expert users, and we see that of the 38 papers here, 30 of them are designed for these expert model developers. So these are people who know deep learning and machine learning and more. And we can actually contrast that with another group in this column, which are the non-expert users. And we see that of the 38, there's actually only 11 of them that are designed to be using non-experts. And this is interesting because it shows that there's 3 times as much work done for these expert users compared to the non-experts. And if you were in the VIS18 workshop just a few days ago, there was some discussion here about non-experts are often a lot of the people and end users of these systems, so they're an important user base that we likely shouldn't be forgetting about. But in the literature today, it's seemingly focused on these expert folks. Okay, the last trend using this big table is actually going to skip ahead to the how column. We're going to focus on once more one specific subcolumn there. And of the 38 papers, 33 of them use this technique of instance-based analysis. And this is taking a single data point or a single data case and running it through the network and putting intense scrutinization and identifying what features of that specific data point contribute towards its classification or its prediction. And we think this is a really common technique because neural networks today often lack global explanations. And what I mean by that is that these modern day networks have hundreds of thousands of network edges and parameters, and there's no natural representation to just put down on screen or on paper that we can truly make sense of. But what instance-based analysis does is enable local explanations. So this is, like I mentioned, just taking one or a couple of data points and really understanding the features of that specific data point that go into its prediction, and then potentially aggregating those up in order to approximate some sort of global explanation. So then as we were doing the survey, we were taking a look at all the places we were pulling papers from. So besides the obvious candidates like VIS, VIS, and Chi, where everyone in the room is likely expecting, the machine learning communities and conferences such as NIPS, ICML, CVPR, and iClear have also been responsive to this visualization work. But we noticed that much of it is coming from workshops that have been spread over both VIS, HCI, and machine learning conferences over the past couple of years. These focus anywhere from human-centered machine learning to just visualization on deep learning in general, or more specifically about just interpretability for humans. This list is fully in the paper, so if you want to look at one of these workshops specifically, there's a bunch of interesting stuff going on in there. And then one last point about this audience I want to mention is that as new deep learning results are hitting archives seemingly every other week now, a lot of them are included with code bases that are open source, where the community can just immediately run experiments and check and reproduce these results. So there's a high value placed on that, and visualization is catching up to that a little bit, but in our survey we found that a good bit of these systems are also open source. So it's a great trend, and there's even been awards for reproducibility at some of these conferences now. So just want to always make sure to say that open sourcing can always progress the field further. Okay, so now let's move on to a few of these research directions where we think the field's going to be moving. So in the machine learning communities, there's a number of complex explanation techniques that are being developed. So one example here is this notion of attention. So in the vision community, given some sort of visual question answering model, where you may give this example image of these two people, and you can ask what are they doing, what the answer is eating. What attention can do is actually create these maps where the model is looking at specific regions of an image in order to tell you this is the part of the image that I think is contributing towards your answer of eating. Another technique is this one called saliency. So this is also looking at what parts of an image in a vision context contribute towards a prediction. This way, just in image classification, we're actually looking at the pixel-wise contribution from the entire image and how it forms some sort of semantic object to make your prediction. Then one last example, also from vision, is this idea of feature visualization, which has been popular for a couple of years now. And it's all about generating synthetic images by maximizing specific neurons in a network, right? You're trying to qualitatively understand what some of these object detectors may have learned in your vast amounts of image data. So these are just 3 techniques of some of these more complex explanations for neural networks that have been developed in more of the AI and machine learning communities. But what we've noticed is that a lot of them are studied in isolation, and they don't quite link up, and they haven't really found their way into interactive interfaces yet. But one place that's starting to do that is Distill, which is this online open source journal for clarity and machine learning. And they're starting to bring some of these techniques like feature visualization and expository-like fashion with some interactions in order to teach both non-experts how general machine learning works, but then also expert users by putting code notebooks directly in the text so you can jump in and start playing with these explanations. Another direction is this notion of human in the loop. So this is likely a phrase everyone in the room is familiar with. And if we were to just take a very high level approach at what it means to have an interactive machine learning paradigm, given some sort of model and a visualization, you can bring that model into the viz, and then use human guidance to close this loop, right? We can remove bias, prevent overfitting, iterate on the model basically, and just steer it to achieve some sort of performance you're looking for. And it's this tight loop where you're using human as well as machine. If we compare that, however, with what is going on in deep learning right now, given some sort of neural network model and a visualization you've seen this morning, you can of course bring this in the viz. But that loop, it isn't quite as tight in the deep learning space. There's not a lot of actionable guidelines for how to take these explanations and understand, do I have a data problem? Is my network too big? Is it too small? Do I need to add a layer? Right, so that loop just isn't quite as tight, and there's some work that's going into making it more actionable, but it's still not quite there yet. Another direction is evaluation. So like everyone here knows, evaluating visualization is not a non-trivial task. And when you add in the probabilistic nature of machine learning models, it becomes even harder. So there's this paper towards a rigorous science of interpretable machine learning. And this was actually discussed once again in the VIS18 workshop just a few days ago. And the authors present a taxonomy of a couple of different evaluation schemas for how to go about evaluating interpretability systems. And they note that these strategies become more specific and costly as you sort of climb the ladder here. And they give some discussion for each one of them about when it's most appropriate to use what type of evaluation for your system. And the last one I want to talk about is protecting against adversarial attacks. So a lot of people, deep learning people in this room have maybe seen this famous picture of a panda. And given some sort of image classification model, everyone has likely seen results that say, yes, there is a panda in this picture. But it's been shown that neural networks are quite sensitive, and given some small change in a noise, when you sum these two images together, you can actually have networks fail quite spectacularly. So we think visualization has a big opportunity here to both identify when data and models have been attacked, but then also defend against them in the future. And actually, later in this session, we're going to see some work that identifies that exact problem. So those are all the big highlights I have for you today. There's many more in the paper, and we put together this little website, which is accessible at the link above. It'll stay up there for a little bit. So I encourage you to go visit this link. As you scroll down, we of course have a link for the paper there. If you keep scrolling, we actually brought that table from earlier in HTML. So every single work there is actually linked to the PDF. So if there's one of those that you're interested in, if you click on it, it will just bring you right to the PDF. And if you scroll just a little bit more, we actually added all of this year's VIS 2018 papers into our schema because we submitted this before the proceedings came out. And this also includes all the papers in this session directly after my talk. At the very bottom there's a little button you'll see it says add a new paper. This website is actually open source and hosted on GitHub. So as new papers come out, if you click that button, it'll just link you to a pull request, and you can add new works and rows to this table as sort of a living document. And with that, that is all I have for you, so I encourage you to visit the link. I've been Fred Holman. This is our Visual Analytics and Deep Learning Survey. Happy to take your questions, and thank you for your attention.
Thank you for a nice talk. There's room for a couple of questions. Please go to the mic and state your name, Sylvia, and your...
I'm Sylvia Mix, TU Wien, Vienna University of Technology. Thank you for this nice, really good, great overview. I'm really impressed, and I'm also impressed about your categorization schema and how you ground it. I read the paper before. I have
to thanks.
what I'm curious of, if you think about the data sets the machine learning, deep learning people are exploring, it's mostly images.
Absolutely.
Did you came across some other data, what they are applying it?
So someone asked this in the workshop on Monday. Yeah, so from the survey, I would say it is 2/3 image vision based. And that's where a lot of the viz work has been done just because images are a naturally visual type of data. There is a good bit of text data for LSTMs and RNNs. So there's a good bit of the rows in there are actually on text visualization. But besides text and images, there really isn't that much that Visual Analytics has hit. There's a bunch of other types of data, as you know, like events or time series that really just haven't made their way into interactive interfaces yet. So there's absolutely a gap there. Yeah, you're exactly right.
Do you have an answer why?
I think vision-based models have been more popular in terms of what they've been able to achieve. They get a lot of press, and it's also just a naturally visual representation of data, unlike a word embedding vector, where it's just a long list of numbers. It's a little bit harder to work with, or at least see what's going on. So I think it's just the notion of image representation makes it easier.
Thank you.
Yeah, of course.
Any other questions? Maybe have a quick one. I really enjoyed your paper and both parts of the talk. What was interesting to me, the second part of the talk sort of answered some of the questions that the first one, which was like, how's your overview of visualization in deep learning any different than, say, visualization for support vector machines or regression models or whatever? And you seem to answer some of this, which I really liked, like the loop is not as tight.
Right.
How did you conclude that from the set of papers? Because there needs to be some other knowledge of how the other stuff works.
So just the broader sense of sort of non-neural machine learning has a little bit more history behind it in terms of bringing a human into the loop. And there's a lot more concrete things about what to do and sort of things we can add for more linear models and SVMs and things like that. But just with the the new prevalence of neural networks saying, don't do feature engineering, just give it all your data and let it figure it out. There's a missing link in the chain there in terms of the features are actually learned, so you first have to understand what those features are, and then know if those are the right features for the task you're trying to do. So there's that missing link there. I think it's pretty crucial.
But so like this is an interesting thing, but the other one is, for instance, you say that few work is focused towards novices and much more to experts. How's that for other interactive machine learning? Do you find that the same, or
that is a good
making a statement?
Yeah, that's a good question. I'm not familiar with just all the other non-neural approaches, and I don't know if it's a more 50-50 split or if it does lean more towards the expert way. So I wish I answered that, but I don't know.
So that's your survey paper next year?
Yeah.
Oh, sorry. Yeah.
Dennis Parra from Catholic University in Chile. I wonder if you found some trend in terms of transfer learning. I'm particularly curious because many times we use, there was this mention of using image models, but mostly we're using models trained on ImageNet. So, for instance, I work in recommender system. We use a pre-trained ImageNet model to recommend art. And in some cases it works well because people are interested in particular objects, let's say cats, and you can see, and the model can, let's say, have features about that. But then you use it in a different model, so there are different cases. You can have issues with bias, or maybe, I don't know, that's my question. If you saw some trend related to seeing how good maybe a model is for transfer learning in terms of vision analytics of these tools.
Right, yeah, so the group, if you look in the paper, it's in the WHO category for model users, not developers. We have a very brief intro just on transfer learning about taking a whole network, chopping off the last layer, and then retraining that last layer for whatever task we're doing some pre-trained network. It sounds like you're already doing some of it. It's mostly just an intro, so you might not get too much from that. But there was, I think the best paper awarded at CVPR just this past summer was all about a survey for transfer learning specifically. So I would point you towards that. I think they looked at a whole bunch of domains for transfer learning to see what sort of networks and what people are doing. So I think that might better help you there.
Thank you.
Yeah, absolutely.
All right, let's thank the speaker again.